Well, what did I learn from the week 7 is we have in Chile we have the clearest skies on Earth, so that's why all the telescopes of the NASA and other investigatory systems we have it here in the northern part of our country. The other thing is light pollution that we humans make by artificial things that make lights, and we can alterate nature nature cycles, and also the cycles of the dreaming that we have. Now for the first activity, it was the Realitech activity. So I'm going to start with the questions. What is the closest planet to the sun? Is Mercury. Then what is the most massive planet that we have in the solar system? Is Jupiter. What is a dwarf planet? And can you at least name one? A dwarf planet is a celestial body that has enough mass to be a planet, and it's orbiting around the sun, but is it's not close. It has not cleared his orbital neighbor. And the most famous example is Pluto. How many planets have rings? And there is two, Saturn and Jupiter. And mention two distinctive characteristics of Jupiter. It is the largest planet in the solar system, and it has no true surface because it's a giant. It's a giant red. It's a gas giant. Sorry. Then mention some moon that has a large amount of water. There is the most common of them is Europa. That is a moon of Jupiter that is believed to harbor a vast surface of saltwater oceans beneath its icy crust. Describe a unique feature of Saturn. It is the best known of a spectacular and complex system of rings, which are primarily made of ice particles. Then, what is the most large red dot in the atmosphere? Jupiter has the giant red spot, which is persistent and a colossal storm system. Why Pluto is considered a dwarf planet and not a full planet? It's because Pluto has the mass to be a planet, but it has not cleared the neighbor around orbit, so it's not considered a planet. Then, suppose you are orbiting the orbit of Saturn. Describe what her famous rings would look like, and particularly how thick they are compared of this size. These rings are incredibly big, like a disc is like a really big disc, about 270,000 kilometers in diameter, but it's really thin. It's averaging only about 10 meters, so it's really thin compared to the giant diameter that they have. What was the most surprising and impressive aspect of your VR experience in the solar system? I think it is the incredibly size of the sun and Jupiter. And how you how do you think the space exploration can influence of understanding the Earth and its place in the universe? It can influence that we can understand the size that we have is very little in comparison to other planets and the sun. After this activity, what would you like to learn about the solar system? I would like to explore more of them because there are a lot of questions that we don't know the answer yet, and it would be amazing to answer these questions. The the next question is, how do you think the virtual technology can be leveraged to improve astronomy education? that this is amazing because you can compare planets, like you can put a planet next to the other and compare them, and I think this is like a really immersive experience. And regarding the experience, what would you think you would improve or change? I think that the experience was nice. I did not try the VR. I saw the video, but and every time I use that, I have headaches. So I don't think it's like the most uh, uh, precious thing for me. For the activity too, uh, you have to look a photo. So I'm going to answer the questions. The size of Mercury is completely wrong because in the photo it seems like Mercury it was bigger than Venus, and it's not like that. Mercury is like really is little is little than Venus. Venus is a lot larger. And the thing that was missing it was the asteroids that have should been between Mars and Jupiter. The activity three is how can we detect the planets in other stars? The astronomers detect exoplanets primarily using the radial velocity method, observing the star wobble. So how to say wobble? It's like when you can see the star, and like the star is pulling us to them, we are pulling out the star from one side, one like this. It's like the star was moving, so you can not seeing the planets, but you can understand that there is a planet because the star moves like really. It's like really little the movement, but if it moves, it's because something is there. The other is the transit method is measuring the star's timing as a planet passes in front. So if the planet passes in front of the star, the the bright of the star will it would decrease a little bit, so you can measure that. And the finally is the microlensing, detecting a temporary brightness of background star due to a gravitational length. And all this information came from the second video. Then, how did the planets form? The process began after a collapsing interstellar gas and dust clouds from the start leaves behind of of a spinning protoplanetary disk of material. Then there are steps that form planets. Then the first one is the dust aggregation. So is when the dust can become like a little balls, and they collide into each other, and they mix. Then of that, the second step is the planet planetesimal formation. So these balls would make a lot bigger and bigger and bigger, and then is the third step is the runaway growth. So these balls that are a lot bigger mix with each other, and they make a really big ball of matter. And the last step, if the planet was terrestrial, is that they form a planet, and if there are a lot, if it's there a lot of mass and gas, it would be like a giant planet formation.